It's August week 3, and the community team here from Deephaven with another demo. Started. Right, so here, got a demo from Alex. Take it.
You bet. Thanks. So this is a cool application of a new way that we put together to do real-time AI in Deephaven. So I found this data set of Amazon reviews that have been collected, were scraped off the web. The reviews, I think, go from 1996 to 2023. So there are 571 million of them, if I'm remembering that number correctly. So I pulled this data in and thought that it would be cool to try to stream through some of this in real time and use a recent Kaggle competition that I saw, where the goal was to train a detector to determine if a certain block of text was LLM generated or human generated, and to use that detector on these Amazon reviews as they come into this table in real time, to try to sort of, use AI to detect AI as it comes in, and try to sort of assess what's going on with these reviews and see if trends have changed over time. So that's the use case. I did not want to try to deal with all 571 million data points. So I think I filtered for just 2023, which itself was like 25 million data points. So if you go to the GitHub repository for this project, that's what you'll find. You'll get all 25 million. So I trained this detector, this LLM detector, based off of a Kaggle entry that I found for that competition, and the script for doing that training is checked in. So this is actually training a real PyTorch model called BERT. It's got like 110 million parameters. So it's a real deal, right? We're not sort of playing around with fake functions, doing funny things here. We're doing real time machine learning and inference. So I trained the whole thing. I saved it here. The model itself is checked into GitHub, so you don't have to spend the 6 hours training it that I spent. I read in all of the data and converted it to Parquet. Now this is super not ideal, right? The place that I got the data from sort of, in theory, provides a way to stream it through without needing to download the whole thing, but I could not get that working for this use case. So what this does is it downloads that data in Parquet format and then streams it using a table replayer. So this is, effectively streaming the 2023 data sort of as it would appear in real time, from Parquet. And that is a point that could certainly be improved. To actually do the data streaming, it's all of this data, it covers sort of all of 2023. So if I were to try to iterate through all of it, it would take, a year in real time, and that's a bit much. So what I did was I set this factor for iterating through the data that both controls the sparsity of data and controls how fast the data flows in. So what I have right now is that we are ticking at 10,000 times real-time speed off of a sample of 1 in 10,000 data points. So on average, these are real-time speeds, but I didn't want to, sit through from for 9 months to a year, how many months worth of data I have, to sort of see some of the long-term trends. So nonetheless, still roughly real-time operations happening here, from that data set, which is cool. And then I actually do the inference, right? So we load up this model that I trained, that's, again, is checked in, saved here. I load that up. I define a table publisher, I define a table listener, and I put together a couple of functions to do the inference, right? So let's see, right Here, we are actually taking data out of the Deephaven table with the listener and computing the inference on the 110 million parameter PyTorch model, returning it and throwing it back out with the table publisher. And it's pretty cool, right? So here we've got, this is the actual table of reviews ticking in. So, right, we have this this text block, and this is the actual block that contains the data. Amazon reviews seem to tick in at about 1 to 2 reviews per second. So that's just, worth knowing. And here are the predictions. So it's reading each of the reviews, it's sticking it through the LLM detector, and it's coming up with a probability, sort of the model's assessment of whether or not this text was generated. And it's doing it basically in real time. So if I sort of move this to the side here, and we just take a look at the timestamps in the source table and the predictions table, it's basically keeping right up. Because we only have, at most a few reviews coming in every second, we actually have time to stick that data through the model and get the outputs in a reasonable amount of time. So there is really no real time delay here. As you increase the throughput, it gets more and more difficult for the model to do all of its computations within the allotted second that it has before the update graph wants to update again. So I worked with Colin a little bit to offload the actual inference work to a thread pool in Python, which is something that I know very little about, and I only started learning in doing this project. And I think there's probably more here to learn. But ideally, it would be nice to offload all of the inference to separate threads, let the engine tick however often it wants, right? Let all the data stream in real time, and have the other Python threads do inference as they're able, right? And as throughput increases, that the rate at which they can do their calculations is going to fall. But eventually, everything will catch up, and that's sort of one of the things that we saw when we were looking at this for super real-time speeds, which I considered and tried out. But yeah, so as far as looking at the table, there's not a whole lot happening. The use case I think is cool, and the next step for me is to put a dashboard in front of this and sort of see how these trends are actually changing over time. I have metadata for all of the items, so I can assess whether these trends are the same or different across different categories of purchases. You can correlate, users with each other and see if there are sort of, it tends to pick out specific user IDs as more likely to be auto-generated than others. And yeah, I think it's a cool use case that I think is actually relevant and going to be more relevant as this technology gets better. So yeah, there we go. That's my demo.
Very cool. I might need that next time I buy something off of Amazon.
Yeah, right.
All right. All right. So that's it for this week. We'll see you next week.